All right. Thank you very much for joining. Give me a couple of seconds to set up this quickly. Okay. So I'll continue the review session we were doing last time. All right. With the following questions. We want to find the equation of a plane. So the plane containing the following lines. So the first line has the parametric equation R of t that is made of negative t, 1 plus 2t, and 2. R2 of t has negative 1, 3 plus 2t, 2 minus 4t. So we want to find the equation of a plane that contains those two lines. So if the plane look like this, then let's just say these two lines, they are like that. I have R1 and then R2 over here. It's just an example. Okay. So the plane P is the one with
Même quand il aura répondu à tous ces messages, Richard aura encore du pain sur la.
apologize. I need to shut something down. Give me a second. Okay. All right. Thank you for joining. All right. So I was saying we wanted to find the equation of a plane which contains two lines. So, all right. We can proceed in several ways. One way that I'll choose is I'm going to choose the two vector, the direction vector of the lines. And then I'll take the cross product of the two to form the normal to the plane. Then I'll choose one point on such line and find the parametric equation actually the equation of the plane. So if I take R1 of t, I can rewrite it as 0 is 0 for the first term, the second term is 1, and the third term is 2 plus t, like this. Then this will be negative 1, 2, and 0. That's the first component. So in that case, the direction vector is negative 1, 2, and 0. And I'll have R2 of t, which will give me for this one, I'll have negative 1. Actually, it's not, it's 0. No, the constant points. So it's negative 1, yes. The second one is 3. And the third one, 2, plus t, scalar multiplied by 0, 2, and then negative 4, like that. All right. So the direction vector, let's call it V1 for the first line. It has -1, 2, and then 0. And the second direction vector, V2, has the component 0, 2, with negative 4. So the normal to the plane is given by n, which will be the cross product v1 with v2. All right, so we need to find such cross product. I have it as negative 1, 2, 0. So n is ijk with negative 1. Let me take a look at the right thing. So the first component will be negative 1, 2 is 2, 0. And the second component is a 0 to negative 4, 0, 2 with negative 4. Then we'll find this cross product. And it will be for the first component, I will have negative 8. The second component will take this with this. So it's 4. If nothing, it's negative 4. And the third component will be negative 2, like that. So that's n. And then what we need to do next is to find a point, P. That is a particular point for the plane. Okay. So such particular point P, we can find it in one of the line. And I'm going to choose one with the coordinates. So I'll choose it as, for this one, I'll say 0. Okay, so the second one is 1. Okay, 2. It's on the line L1. So with this particular point, if M is on the plane P, then MP, the vector MP, or I prefer PM dot N has, those two vectors are orthogonal. So it means that x minus 0, y minus 2, mute yourself, z minus 2 dot, the dot product that I just found, negative 8, negative 4, negative 2. Oh, Laura, mute yourself, okay. So PM dot N, the PM and the N are orthogonal. So I'll have negative 8 with x minus 0, minus 4, y minus 2, minus 2, z minus 2 that equals 0. I can simplify by 2. Actually, negative 2 if I prefer. That would be 4x minus plus 2y minus 2 plus z minus 2 that equals 0. So this is 4x plus 2y minus 4 plus z minus 2 that equals 0, which is 4x plus 2y plus z minus 6 minus 6, or we can just say that equal positive 6. Okay, so it's like that. We could have choose another point, but the equation has exactly to be the same. Okay. Any question? No? All right. Or something else that you could have done is you find the menu to do this. As long as it follows the logic, that's fine. So, next question. Assume we have 3 points. The point A with coordinates actually 0, 1, 2. B has the components 3, 2, 1, and C will have the components 5, 2, 0. Question are these 3 points A, B, and C, are they on the same line? Is the equivalent to say that are the collinear? So you want to explain. All right. So I'm saying that the point A where has the coordinate I just gave, if they were on the same line. So I have the point A here, the point B here, and the point C that is here. So if they were on the same line, we would have the vector AB and the AC that will be parallel, or just, you choose another, let's say the vector actually AB and BC that will have been parallel. Okay, so if they were on the same line, okay, so which means the cross product AB with AC will have been equal to the 0 vector. So let's find such cross product. The vector AB will have the components 3 minus 0. The second component is 2 minus 1. And the third one is 1 minus 2, which is 3, 1, negative 1. First component, the vector AB. So the vector AC has the coordinates C. So we are saying C minus A. So it's 5 minus 0, comma, with 2 minus 1, comma, 0 minus 2. So with that, we'll have the component as 5, 1, and then negative 2. Negative 2. So overall, the cross product JK AB is 3, 1, negative 1, then 0 like this, 1 with negative 2. So we want to check if this is a 0 vector or not. So I'll have negative 2 plus 1 for the first component, which is negative 1. So it's good to say that this vector is not going to be a 0 vector. So then next, that will be negative 6. And the third one is 3. Is it negative 6 for the second? So positive 6. The third one is 3, which is different from the 0 vector. So these 3 points are not collinear. They're not on the same line. Hence, the 3 points are not on the same line. Any question? Do you have any question? Okay, so let's continue. If you have any question, just put them in the chat. Let me read the chat a little bit. It depends on the class. So if you are in my, someone is asking the question, when will my, the midterm start? So if you are in the 1 p.m. class, it starts at 1 p.m. and we finish at actually 1:50. But if you are in the second class, it starts at 2 p.m. and we finish at 2:50 on Friday. No, 13.6 and 7 are not on the tests because we didn't cover them. Y minus 1. Yeah, again, the 13.6 and 7 are not a part of the test. Scalar multiple questions. What is the scalar multiple question? Yeah, you mean scalar triple products. It's not useful in this case because we just have 3 points. And those points, we want to see if they're on the same line or not. Okay. So it's better if you use this parallelism of the two vectors, which is equivalent to say whether or not the cross product between the two of them is 0. Okay. All right. So another question. Given the path of a particle, let's say P like this, that is made of the following curve. I have R of T. The R of T is made of T square 3 and T cube. The T is between 1 and 5. So the first question is this. Is R of T an arc length parameterization? Well, we just saw today that for this to be an arc length parameterization, the speed has to be equal 1. So how can I check if two vector intersects? I mean, the two vector, intercepting two vector, I don't know what you mean. But so if I have two vector like this, like that, I don't see the point of doing this because you can move this vector onto this to make it look like that. The vector that is here can be moved onto this one, or the one that is here can be moved separately here. So it doesn't really bring any interesting information to do that. All right, so let's continue. I believe I answer your questions. Okay, so let's continue. So we want to check if R of T is an arc length parameterization. So for that, let's find the speed for all of the T. So the speed, the derivative, which is 2T, comma, 0 here, 6T squared. So the norm will be the root of 40 squared plus 0 squared plus 36T to the 4th. So this will be, I can take the T squared out. I'll have then T, the root of 4 plus 36T squared. So which is different from 1. So there exists T for which the expression we just found here is not 1. Okay. So for this reason, this is not an arc length parameterization. R of T is then not an arc length. Parameterization. It's not. If it were the case, then we will have actually the, the speed, which is the magnitude of the derivative of the parametric equation, will have been equal 1. Then next, we wanted to find, next question, find the arc. Find the arc length of the curve for t is between 1 and 5. Right. So what we're saying is this length L is the integral from 1 to 5 of the norm of r prime of t dt. So that will be the integral from 1 to 5 of t, the root of 4 plus 36 with t squared dt. Okay. So then I can take this integral on one-on-one basis. So this means that I can do a u sub here. Sorry. The u sub u, say it's the root of 4 plus 36 t squared. Okay. So for that, I have du, that is 72 t dt divided by 2 root of 4 plus 36 t squared. So that will be du divided by 36, because I'll simplify this with 72. Okay, divided by u. That's, you don't need this. Yeah, it's like that. Okay, so that will be dt t, where the root of 4, all this is u. So it's t dt is u divided by 36 du. Okay, at the end, let me finish this integration over here. I'll use another color, green, so that it makes sense. I'll change the bound for the integral. If t equal 1, okay, so that will be root of 40. All right, and if t equal 5, so it's 36. 36 multiplied by 25. Okay, it's 3,600 divided by 4. So which is 900 plus 4 is the root of 904. And I don't know if you can simplify this, but you can but just leave it like that. Okay, so I'll have 1 divided by 36 u du. So it is u squared with du. All right. So this will give me 36 by 3 to the cube, which you take between the root of 40 and the root of 904. So it's 1 divided by 108 with the root of 904 cube raised to the cube. And well, I don't know how, I mean, this can be done, but I prefer we spend the time doing something more interesting. Are there questions for me? Are there questions for me? Okay, so if there is no question, let's continue with another assignment. Given R of t with t like this, find the equation of the tangent line no, the u sub, I took the full radical to be the u sub. The root of 4 plus 10 is 60 squared, and I operate. Okay, that's what I did. I said that the root u substitution is it clear, Evelyn? Is it clear? Okay, great. So, right, someone can use another substitution. That's totally fine. All right. So we wanted to find the parametric equation of this time. Find the equation of the parametric equation. Okay, of the tangent line. Le graph at t that equal to okay, so at t equal to, you need to find the direction derivative and a fixed point. For a fixed points are at equal to, and this will have been 2, 4, if 8. When the point is fixed, then we need r prime at equal to this will be 1, 2t, 2t squared. Find that at equal to. So with that, I have 1, 4, 12. That's the directional vector. Okay, so the line L at t, so that will be with the t that is any arbitrary real number. All right, that's the parametric equation of the tangent line. So again, this is the direction vector. And these points represent one particular point on such line. Do you have questions for me, guys? All right. If you don't have a question, then I'll keep doing this. But I just need to change the assignment. If you give me a second. All right. So let's continue. We said that a particular motion can be represented by arrow t, which is 1 minus 2 the sine of t. And the second component is 1 minus 2 cosine of t. And there is a third component, which is 0. First question. Find the speed at the time t. That is 2 seconds. So the speed derivative with respect to t of s, the arc length function, release of, well, actually we know how to find that directly. So like this, and this will have been r prime of t is minus 2 with positive 2. Okay, so like that. And if we take the speed, then this will be the root of cosine of t squared sine of t squared. With that said, we will have the 4 cosine squared so it is 4 cosine squared t plus 4 sine squared t. With that said, okay, and this will have been the root of 2, the root of 4, which is 2. So this is the speed. Since it's constant at 2, there is 2 seconds, the speed derivative with respect to t of s at t equal to just a constant. So there is no consequence on that. Any question? Any question? All right. If you don't have any question, let's continue. Determine. So determine the distance traveled. So the distance traveled So the distance the particle travel. All right. The distance, so that's the arc length then, is the integral from A to B. Okay. All right. So when you take the norm of R prime of T, then you're taking the norm of the minus cosine of T to the positive sign, the sine of T. But the zero don't contribute, so putting it or not doesn't matter. So the speed, it's for that will be true. Then to find the distance traveled is the integral from T that is 0 to pi of 2 T here dt. So this will be T squared I'll leave you digest, but any question? Any question? To multiply this by 2. Okay. The next question is this. Now, the A and B are given by the assignment. So we want to determine the distance traveled by the particle for T that is between 0 and then 2 pi. So they are known a priori. Any further question? No. Okay. So then the last assignment, the last question of this assignment is to find the arc length parameterization. Okay, so let's do that. So for this arc length parameterization, we said if R of T is 1 minus 2 sine of T, 1 plus, actually, not T. Then finding the arc length parameterization means that we do S of T the area function of 0 to T of the speed. So, but not me, just need to do the calculation. I think we did this before. It's okay if I repeat it. So 0t with minus 2 cosine of t like that. So we want to look for the norm. So let's see what the norm is about. We already proved that the norm here is 2. So s, which is s of t, the integral from 0 to t of 2 dt. With dt. And this is 2t. Exactly what we were discussing class. So with that, I have s, that is twice t, divided by 2. So the arc length parameterization of the curve g of s, that will be 1 minus 2, the sine of s over 2. And the second component, any question before we move forward? Mhm. All right, then we have to find the bound for s. So the t bound, someone asked the question. The bound for s is, since s is 2t, we need to extract the t. Okay? And once that is extracted, I can write the parametric equation of as 1 minus 2, the sine of t. One minus 2 cosine and 0. But we need to tell where this s is located. Because the t is between 1 and 5, s one and 5. Yes, come in. Come in. Come in, please. Oh, okay. Thank you very much. Yes. I will do the swap then. Thank you. So s divided by 2, which is between 1 and 5. Then the s then is 2 times is 2 s with 10. So we write g of s, that is 1 minus, so 1 minus twice the sine of s divided by 2, 1 minus 2 cosine of s divided by 2. And there is a third component, so that will be the zero component, s divided by 2 over here. And 0 with the s that is between 2 actually and 10. Any question? Any question? No question? Yes, so what is the question of my right? I couldn't, why is the integral of 2t instead of just 2? Did I write the integral of 2t? In which you mean, no, it's just it's not 2t, so, okay, so let me redo that part. Okay, so the question above said to, it's 1 minus 2 sine of t, 1 minus 2 cosine of t. So that's r of t. And if that r prime of t is going to give me minus t cosine t with 2 is something. So the norm r prime of t, it's the magnitude here is 2. Okay, so then the length is the integral from 0 from 1 to where it depends. So yeah, the distance traveled from 0 to 2 pi is 2 here then with dt, and that will be twice 2 pi minus 0. So this will be 4 pi. So is that what you meant? Yeah. Yeah, okay, good. No, if I did it the other way, so it's just a distraction. Look, something is happening to my iPad. If I move back, my disk is full. So if you ask me the question, I can repeat it over here. It's just screening. And right now, I just was awarded with this new iPad, so which I'm going to use for our next review, and we will not have those problems. But yes, in the meantime, feel free to ask those questions, and I'll go back and solve them again. Okay, so that's why I'm not. You see, if you go back, everything is empty. So, by the miracle. But yeah, shall we continue? Shall we continue, guys? Yes. All right. So, I have. I don't know if I did this before. I think we did that. So we have an intersection of a line with a plane. And then I think we did it last time. So I don't want to repeat it. Otherwise, we will lose time. So let's continue. Give me a second. So, okay, great. Yeah, I think I did this before. So we did the right triangle. We did that. Oh, it doesn't matter if you're repeating some of them. It's totally fine. Okay, so let's say we have the point P with components. The point P will have the components topologies, let me find the stuff. Yeah. So it is 2, 9, 1. The point Q has the component 5, 2, 5. And the R has the coordinates 2, -7, -2, and 4. Okay, then let the vector A be PQ, and the vector B, let's call it PR. So question, you wanted to find the projection proj of the vector A onto B. So that's easy. We need to find the proj of, let's see what are the components of the vector A. A is P, Q. So it's 5 minus 2, which is 3. 2 minus 9, -7. 5 minus 1 is this. So projection of this vector into PR. PR is 5. -11 with 3. So the projection vector proj of the vector A onto B is A dot B, B dot B, and this, to which multiply the direction vector of B. Or if you prefer, you can write it also as A dot B divided by actually the magnitude of B, B magnitude B. It's one of them. It will do the same thing. So the dot product of A and B, this will be, I'll do the math immediately, is 15 plus 77 plus 12 plus 12. We divide that with B dot B, 25 plus 121 plus 9. So that would be 17 plus 77 is 884 divided by, that's 155 in the direction vector B. So the B vector is 5, -11 with 3. So the projection goes fast. All right. Then the question is this. Do P, Q, and R lie on the same line? Same line. They want us to explain using the projection we found. Explain using the projection. So look, if these two or these three vectors were on the same line, or these 3 points were on the same line, so let's say I have a P here, Q here, and R over here. So the vector PQ, the vector PR. PQ is the vector A, and PR, that's the vector B. So if those 3 vectors were on the same line, then the projection of the vector A onto B would just have been A. That's what you get. But this is not the case, which is not the case. But because when we found the projection vector, it doesn't match the vector A, which is not the case. Conclusion, those 3 points are not on the same line. Okay. I believe we have a lot of assignment, plus the one that we did last time. It should cover anything you need to know before tackling the midterm on this Friday. So, having said that, I wanted to thank you